the mole equation is the last thing in this unit. It is crucially important that you can use the mole equation and the concept of the mole when you get to Chem 20. One of the first things you will do in Chem 20 is reaction stoichiometry. Okay? And that means that you would have to be able to calculate in grams the amount of products that could be produced in a reaction if you knew the mass of your reactants. Okay? The mole equation allows you to do reaction stoichiometry, and being able to calculate how many grams of a product you might produce could be important, especially if you were trying to produce large quantities of something on purpose. So we need to understand that the mole is a unit of measuring amounts of material. Okay? We can use liters for that, we can use grams for that, okay? But when it comes to the mole, it's actually like, if I say I have 48 donuts, how many dozen donuts do I have? 4 dozen, right? Well, a mole is like a dozen, okay? We always know a dozen represents how many? 12. Well, a mole always represents the same number of particles, okay? Which we'll get to in a minute, okay? So rather than saying I have 48 donuts, sometimes we go, I have 4 dozen. It's quicker. And everyone knows how many are in a dozen, so they can do the math quickly, okay? Now, I'm not saying you can do the mole math quickly, but it works that way. Okay, we're going to look at the relationship between moles, mass, and molar mass, and use the mole equation to solve problems. There are 4 ways I can ask a mole equation problem, and we will go over all 4 every day this week. Okay, so you'll get to see it lots of times. Now, the mole equation looks like this. N equals little m over big M. It is the worst designed formula ever. Okay, we have 26 letters in the English alphabet. This formula uses the same letter twice, and it only has 3 variables in it. That's poor planning. Okay, and the only other letter it used is the only other letter in the alphabet that sounds like the letter they used twice. N equals m over m. Terribly confusing. Okay, so we know N is the number of moles. So it's not hashtag moles, that stands for number. Okay, number of moles. Little m is mass in grams. Big M is molar mass. Okay, and that will be in grams per mole. Okay, so molar mass is the mass of 1 mole of that material. Now, while that may sound like something new, it actually isn't. Okay, you've been using the molar mass of elements, okay, all along here. So if I have 1 mole of beryllium, it'll have a mass of 9.01 grams. Okay, if I have 1 mole of calcium, it'll have a mass of 40.08 grams. Okay, so the atomic mass is actually also the molar mass for each element. Okay. All right, questions so far? All right, so if we can measure the amount of stuff with like liters and grams and stuff like that, why would we come up with something else? Okay, I didn't expect anybody to have an answer. It was kind of a rhetorical question. The reason is because the mole actually refers to the number of individual particles that we might have in a pile or a sample of a material. Okay? If I just measure its mass in grams, that's all well and good. It tells me the mass, but it doesn't really tell me how much or how many particles there would be. The mole can more directly do that, right? So, as we were saying, we can measure the amount of a substance in grams or moles. Okay, it could just as well be liters or tons or molecules. But we can't possibly count the number of molecules in even a small sample of material. Okay, so the mole helps us to figure out how many particles there would be based on the structure of the atom or molecule of that particular material. Okay, so we abbreviate mole as mole because we're very busy. Don't have time to write the whole word, so we take one letter off. You laugh. We have an abbreviation for at. We're that busy. Okay? It's ridiculous. Anyway, so the mole is just like, as I was saying before, just like a dozen. One mole always represents the same amount. It's this much. 6.02 times 10 to the 23 particles. Why would anyone pick such a random number? For a dozen, like, it's 12. 12's not so random. That kind of makes sense. Why would anybody pick this absolutely giant number? Okay, this is 602 with 21 more zeros behind it. Is that a lot? It's a lot. Okay? It's a very, very big number. But that's because atoms and molecules are very, very, very small. Okay? To give you an idea, if I had 1 mole, which is 6.02 times 10 to the 23 particles of hydrogen, it would have a mass of 1 gram. Okay? And 1 gram of hydrogen gas, there are this many particles. Okay? That's how small atoms are. Okay? Really, really small. And in fact, it's hydrogen that led us to this number. Okay? This number wasn't picked at random. It was actually calculated using hydrogen. Hydrogen is the simplest atom. It contains 1 proton, 1 electron. That's it. Okay? So, if we had, what they did is they figured out if I had 1 gram of hydrogen and I know the mass of 1 proton and the mass of 1 electron, how many atoms of hydrogen would be in there? Okay? They used hydrogen because it was the easiest, and that's why the molar mass of hydrogen is so close to 1 gram. Okay? So, that's the number of particles, atoms of hydrogen, that there would be in 1 gram or 1 mole. Okay? Now, what if I have 1 mole of oxygen, or sorry, let's say 1 mole of sodium? Would it still have this many particles? Yes. In the same way that if I said I have a dozen donuts or a dozen eggs, I have how many of each? 12. A dozen is always 12. A mole is always this many. Okay? Always, always, always. All right. So this number was calculated by a guy named Avogadro. Okay? That is Avogadro's number. And it is on the back of your periodic table, okay, with some of your other useful constants and numbers. Right? So it's not a number you have to memorize, but you probably will because we're going to use it a lot. Okay? But that is Avogadro's number. Now, why did he choose the mole to represent that? I don't know. I have a theory. And when you see his picture, you'll know. Okay, so if I want to calculate the molar mass of something that's not an element, because obviously I can read the molar mass of elements right off the periodic table, it's right there. But if I want to calculate the molar mass of a compound, then I have to add up the atomic masses from the periodic table. So for example, with water, okay, which would be H2O, right, I would look at the molar mass or atomic mass of hydrogen, which is 1.01 grams per mole. And how many hydrogens are there? 2. So I'd multiply that by 2. And I would add to that the molar mass of oxygen, which according to your periodic table is 16, okay, which would give me 18.02 grams per mole. Okay? So that that means that if I have just over 18 grams, that's 18 milliliters of water, so that's about a tablespoon of water, actually a teaspoon of water is 15 mils, okay? Then that would have 6.02 times 10 to the 23 molecules of water in it. Okay, so molecules, super small. Okay. Does everyone follow what I did here? All right, so let's say I have okay, using your periodic table, see if you can calculate for me the molar mass of magnesium phosphide. Okay, let's look at the first two here. So for sodium chloride, okay, for sodium, our atomic mass or molar mass for sodium is 22.99 grams per mole. There's only one sodium, so I just leave it like that. And I add it to chlorine, okay, which is 35.45, okay, and so that's going to give me 22.99 plus 35.45, okay, is 58.44 grams per mole. Okay, questions on the first one? Okay, that's about as easy as they get, that one. Okay. And then for our second one, we've got iron, okay, iron 3 bromide. The Roman numeral does not affect its mass, obviously. Okay, so we've got, what is iron again? 55.85. Okay, there's only one iron, so I leave it like that. Plus 3 bromines, 79.9 times 3. Okay, so we're looking at 295.55 grams per mole. Okay, questions on the second one? All right, give you some time to get further ahead of me then. Okay, let's look at number 3 here. So for number 3, okay, we've got diphosphorus pentaoxide. So we're going to go 30.97 times 2. That'll account for our 2 phosphorus atoms. Okay, plus 16 times 5. That'll account for our 5 oxygen atoms. Okay, so 30.97 times 2 plus 16 times 5. 141.94 grams per mole. Okay. How many people have done all 5? Okay. I'll give you one more minute here and then we'll go through the last 2. Okay, looking at the last 2 here. So I've got ammonium sulfate here, okay, and I have to do this element by element. I'm not going to find the molar mass of like polyatomic ions. I can only go element by element. So there are 2 nitrogens, okay, 14.01 times 2. There are 8 hydrogens, 1.01 times 8. Okay, there's 1 sulfur. Is it 0.7 or 0.6? 0.6, right? 0.7. Okay. And then there are 4 oxygens, 16 times 4. All right, so if I put all that together, so 28.02 plus 8.08, that's my hydrogens, plus 32.07 plus 16 times 4. 132.17 grams per mole. Okay, for my ammonium sulfate. Okay, that's about as tricky as they get. Okay, where you got 2 polyatomic ions joined together. Okay, you got to do a lot of figuring. Right, and then for our last one here, we have scandium carbonate. Okay, so scandium has a molar mass of 44.96, and there are 2 of them. Okay, and it's with carbonate, so there's 3 carbonates. That means there's 3 carbons, so 12.01 times 3 plus 6 oxygens, sorry, 9 oxygens. Okay, so 44.96 plus 12.01 times 3 plus 16 times 9. All right, 224.9, oh, I forgot to, sorry, I got 44.96, I forgot to put 2 scandiums in there, 269.95. Okay, everybody all right with that? I mean, basically you're just looking up numbers off your periodic table and adding them up. Okay, it's nothing too terribly difficult. Now, the reason we have to be able to do this is because these things we just calculated are this number in the mole equation. Okay, so for basically every mole equation calculation we do, we're going to have the molar mass, which we can always get because we'll always have a periodic table. Right? They tell us what the material is, we can always calculate its molar mass. Right? So we're always going to know big M in a mole equation calculation. All right, questions there? So when we look at a chemical reaction, okay, and it's balanced, the reason we balance these equations is because we want to have the same number of each type of element or atom on both sides. Okay? Well, the way we can look at that is, if I look at this reaction here, I could take it literally, and I could say that 1 molecule of nitrogen gas is reacting with 3 molecules of hydrogen gas to produce 3 molecules of nitrogen trihydride. Would I even notice that reaction? I wouldn't even be able to measure that. 1 molecule of nitrogen gas reacting with 3 molecules of hydrogen gas. Molecules are tiny. Okay? So realistically, this is more like saying 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of nitrogen trihydride. Okay? When we do that, the mass will be conserved on both sides. We'll have the same number and same amount in grams on both sides of the equation. Okay? Everybody all right with that idea? Okay, so we could look at it from the standpoint of particles. That was the first thing we did, literally 1 molecule of nitrogen. Okay? 3 molecules of hydrogen makes 2 molecules of nitrogen trihydride. We could look at it that way. Okay? Or we could look at it in terms of like moles and things like that. That's Avogadro. You ever seen a mole? Like the animal? That had to have been his nickname. He just looks mole-ish. And it's probably just the cut of his suit, but it makes it look like he's got like no neck. Okay? And moles are like that because they have to tunnel, so they have like thin shoulders. I don't know. Just my theory. Okay. So we could say it's moles, most likely when we're doing reaction stoichiometry like you're going to do in Chem 20. Okay, those numbers are going to represent moles. Those coefficients you put into balance are going to represent moles. Okay, and it could be mass as well. Okay, we could say that in this reaction, okay, if I have 1 mole of nitrogen, that's going to be 28 grams. Okay, if I have 3 moles of hydrogen, that's going to be 6 grams. Okay, which gives me 34 grams of reactants in total. Okay, well, in the products, I would have 34 grams of nitrogen trihydride. Right? Mass would be conserved. Right? That's what reaction stoichiometry would allow you to figure out. Okay, you're never going to have to do that in Science 10. Okay, but it's the first thing you're going to do in Chem 20. Okay, so our formula for the mole equation. Number of moles, okay, N equals mass in grams divided by big M, molar mass in grams per mole. Now, you are going to have to manipulate this equation to solve for things other than the number of moles. Okay? How do we manipulate equations? use algebra. Okay, we use algebra to manipulate equations. All right, because I know that somewhere along the way, some well-meaning teacher, well-meaning, wasn't the right thing to do, but they meant well, taught you something like this. I'm sorry they did that. It's entirely their fault. You can't use a triangle in high school. Okay? Like, would it work for this formula? Yes. But it won't work for this one. You're going to use that in Unit 3. You got a triangle for that? That has 4 things in it. Triangles. 3. So, I don't know what you're going to do. Maybe you need like a rhombus or something. Okay? But a triangle ain't going to cut it. Okay? And that's just one of many formulas that we will use for which triangles suck. Okay? A triangle is a crutch. You're better than that. You don't need a crutch. You don't have a broken leg. Okay? Your math skills are perfectly intact, and you will be able to perform algebraic manipulations of equations because it's not hard. Okay? This is what's used by people who fear algebra. And algebra is not to be feared, okay? Because it isn't that hard. Okay? You know how many rules there are for algebra? 3. Okay, guys, I got through university physics with 3 rules of algebra. Okay, and I mean, you get into some crazy, crazy formulas, okay, like this one. Or this one. I don't even know what you do, but the square root in a triangle. I don't know how you factor that in. You have to square root your triangle. I don't know what that looks like. Okay, that's pretty crazy. Or this one. Got a triangle for that? Have I made my point? You're done using triangles to do math. Okay? They do not work. So, if I want to manipulate that equation, let's say I want to manipulate that for little m. What do I have to do with big M to move it to the other side? No? Right now, what am I doing with big M? So the formula says n equals little m divided by big M. What am I doing with big M right now? Right. I'm dividing by it. So if I want to move it to the other side, what do? I multiply by it. That's the first rule of algebra. Write these down. And yes, I do see the irony that a triangle has 3 sides and there are 3 rules in algebra. Okay, the irony is not lost on me there. Okay. And first rule of algebra is that if you want to move something, you do the opposite operation. The second rule of algebra is the golden rule of algebra. What you do to one side, you must do to the other. Okay. You don't even need the third rule for this equation, but we're going to go over it anyway. Okay? Okay, the third rule of algebra is that if there's an order to move things in, you start with what's not attached to what you're looking for first. Okay? That probably doesn't make sense right now, but it's going to make sense in about 2 minutes. Okay, so looking at this formula, I only need the first 2 rules for this formula. Okay, I'm trying to solve for m, little m. Nothing is attached to little m. There's nothing here beside it. Okay, so I don't need the third rule. To get it by itself, I need to move big M. Okay, first rule says that if I want to move something, I perform the opposite operation. Right now, I'm dividing by m. So what do I do to that side to get rid of m? Big M. Sorry. Oh, sorry.
Multiplication.
I use multiplication, right. Right now I'm dividing by big M, so I would multiply. Now I got m divided by m. Well, m divided by m is 1, so it's gone. Now I follow the second rule. What I do to one side, I must do to the other. That way I didn't magically destroy m, it went somewhere. Okay, now it's on the other side. Am I solving for little m? Okay, and all I had to do was follow 2 rules of algebra. Okay, if I want to move something, I do the opposite. Okay, what I do to one side, I do to the other. This is probably better illustrated with this formula, which we will use later on. Okay, y equals m times x plus b. I want to manipulate for m. So I want to get m by itself. What should I move first? In this equation, what's not attached to m? B. Okay? B is not attached to m. X is attached to m. Okay? So, what am I doing with b right now? I'm going to subtract it. Right now I'm actually I'm adding it, right? The equation says plus b. So if I want to move it, I do the opposite. So if I have b minus b, what's b minus b? Right. All right. What I do to one side, do to the other. Y minus b equals m times x. Okay. I still don't have m by itself. What do I move now? X. Right now I'm multiplying by x. So to move it to the other side, I would need to divide by x. Okay. x divided by x, gone. What I do to one side, I do to the other. Divide by x. Am I solving for n? And it doesn't matter how crazy the formula gets. Those three rules will always allow you to manipulate it. Okay? In any linear algebra, that will work. Okay? When you get to calculus, that's a totally different thing. Okay? Don't ask me how that works. I didn't understand it. I memorized the examples in the textbook and wrote them down on the final exam and got part marks for method, which was smarter than half the people in my class who didn't do that well. Okay? All right. Is this making sense? So I'm trying to tell you, I'm not that like strong a math person. I teach physics and I'm not that strong a math person. Okay? You show me what you're doing in math 10 and I'm gonna like, it's gonna be a struggle for me. I'm gonna have to work through it. But algebra, no. Algebra's not hard. Okay? You can do it. It just takes a little practice. Okay? Those three rules will get you through any linear algebra you have. Okay, let's look at some examples of this. Okay, I want you to write this question down. This is the first way that I can ask a mole equation problem. Okay, there are 4 ways. I don't know if we'll get through all 4 today, but we'll try. So, the first thing you want to do with a mole equation problem is write down your givens. Okay, and what we mean by that is write down the things the question told you or gave you. Right? So the first thing it says is how many moles? What is it asking me to solve for? Number of moles, which in our mole equation is represented by n. Okay, so n is my question mark in this one. I'm being asked to solve for it. Okay? It tells me that the material I'm dealing with is calcium chloride. Since I know the formula, what can I calculate with that? We just did 5 examples of it a few minutes ago. Molar mass. Okay? If I know the material, I can calculate that material's molar mass. Okay? Since this is calcium chloride, that's going to be 40.08. The atomic mass for calcium, plus 35.45, which should be 110.98 grams per mole, I think. I probably shouldn't do math in my head, but I did. Okay, so now I've got big M, and then it says, how many moles of calcium chloride are in 90 grams? What's the 90 grams? Sorry, times 2, yes. That's how you get 110. Yeah, do the math in my head and I lose my focus. Okay. All right, what's the 90 grams? What don't I have up here that's in the mole equation? Little m. Okay, so I've got 2 parts of the mole equation, little m and big M. And I'm looking for n. Hey, you get 1 mark for this. Okay, if this is on a quiz or a test, writing out what the question told you is 1 mark, and calculating your molar mass. Okay, n equals little m over big M. You get a mark for that. You identified what formula you should use. I know that right now that seems a bit superfluous, but by the end of the course, when there are like 24 formulas to choose from, it's worth a mark. Okay. Do I need to do any algebra? Not for this one. It's asking me to calculate n. The formula calculates n as it sits. So all I have to do is plug in the numbers. 90 grams, okay, divided by 110.98 grams per mole. Okay? Sometimes I even give a mark for plugging in the numbers in the right places. Okay, so this is going to be 0.81 moles. So that could be a 3 or a 4 mark question. Okay, was there much to that? Not really. Okay, questions with that one? All right, so what's another way I might ask this? In this one I gave you the ability to get molar mass, which you'll always have, and I gave you mass, and I asked you to find N. What's another way I might ask it? Right? Yeah, and solve for little n. Like this one. Okay, so write this one down. We'll walk through it real quick here. All right, first thing we do, we write down the givens. What is the mass? Okay, I'm being asked to calculate little m. Of 4.5 moles, what did they give me there? N. Of magnesium bromide. All right, now, what's the formula for magnesium bromide? How much of this question will you get right if you don't get the formula right? None of it. Yeah. Okay? You won't get anything right if you don't get the formula right, because you won't get the molar mass right, which means you're plugging in a number that's wrong into your formula, which can only give you an incorrect answer at the end. So, being able to write formulas, super important. Okay, so we got 24.31 plus 79.9 times 2. I think we did this one, didn't we? No, we didn't. I tried. 24.31 plus 79.9 times 2. 184.11 grams per mole. Okay, so I know N, I know big M, I'm looking for little m. So to get little m by itself, I have to move big M over to this side. What do? Multiply, because right now I'm dividing by big M. So I multiply this side by big M, that'll cancel it. What I do to one side, I do to the other. I've just manipulated to solve for mass. Okay, so you'd get a mark for that. You'd get a mark for your algebra. And if you have to do any manipulating, you get a mark for it. Okay. And then we just plug in our numbers. So 184.11 times 4.5, so this is big M times N, equals little m. So 828 we'll say 50, we'll round it to 2 decimal places. Grams. All right, so you'd get a mark for your givens, you'd get a mark for the mole equation, a mark for your algebra, possibly a mark for plugging the numbers in, and a mark for the answer. It's either 4 or 5 marks. The last 2 ways I can ask a mole equation question involve using Avogadro's number. Okay, now Avogadro's number, this one, tells me how many particles, be they atoms or molecules, are in 1 mole of a particular material. Okay, so if I told you that you had 6.2 moles of, I don't know, that stuff, calcium nitride, how many molecules do you have? Okay. This is the number of molecules in 1 mole. This is how many moles you have. let me ask it a different way. I have 2 dozen eggs. How many eggs do I have? 24. How did you do that? Right, you took the number of dozen and multiplied by the number of things in a dozen, 12. What do I need to do here? This is the number of moles. This is the number of particles in a mole. How do I figure out the number of particles? I multiply these two numbers together, okay? For some reason it's like super, like there's a block there when it comes to doing this, but when I ask you the dozen question, it's right away, okay? You guys know what to do right away. This is exactly the same thing, okay? Remember that Avogadro's number is like 12 is to a dozen. Right? So if I want to figure out how many particles, I take the number of moles, I multiply by Avogadro's number. In fact, for this question, I could have picked any material I wanted. In 4.5 moles of anything, there's, or sorry, 6.2 moles of anything, there's 6.2 times 6.02, okay, particles. Doesn't matter what the material is, okay? There's just going to be that many particles. So, in my calculator, what this looks like is this. I take the 6.2 moles, the number of moles, n, and I multiply by Avogadro's number, which has to be enclosed in brackets on your calculator. Okay? Otherwise your calculator will try to do order of operations and it'll mess up. Okay, so I go like this, and I go 6.02, and then I hit the second function button, and I hit the comma on a TI. Okay? If your calculator is not like this, it'll have an EE button or an EXP button. Okay? You'd hit that, and it'll put a little E, or it'll go times 10, and it'll have an X. Okay? 23. That's how many molecules of calcium nitride there are in 6.2 moles. Okay? 3.73 times 10 to the 24 molecules. Okay? So I would write that like this. Okay? Let me ask you something different. I have 36 donuts. How many dozen do I have? How'd you do that?
Dozen times 3.
Right. 36 divided by 12. Right. You took the number you had and you divided by the number there are in a dozen. That told you the number of dozen you have. Well, if I said how many moles of something in, let's say 9.5 times 10 to the 23 molecules. Okay, so I give you the number of molecules and I ask you to find the number of moles, then you go okay, and you'll get the number of moles. Okay. So that we will have to use tomorrow when I go over the 2 types of mole equation questions that involve using Avogadro's number. The extra step is just either multiplying or dividing by Avogadro's number. That's all there is to it. It's the only extra step there is. Okay? All right, remember, your talks and projects are due tomorrow, so make sure you have those submitted on Google Classroom by 8:30 a.m. Right? I will post the unit exam review package today. Okay, so you'll have that to look at. And obviously your reactions assignment, which I already know a lot of you are done already, okay, is due on Friday. Incidentally, if you want to submit your reactions assignment, okay, because it's done, I'll take them.